Hi friends, this is Alagappan. This video is going to illustrate how to approach Dataweave transformations. Dataweave is one of the powerful components in the Mule platform, which really does the transformation of one data, like one form of data to another form. So ideally in an API world, we often require transformation. This transformation is really needed to convert from an XML to JSON or even some other formats, and even vice versa, or even trying to plug some elements from big JSON and try to uh, send it to some other thing. So API and transformation. So transformation is heart of the API. So we often used to write Java code. So Java code requires compilation and interpretation. So and even with future Java upgrades, we may need to really um, backtrack our Java code whether we are using any Java functions or not, the deprecated functions or not. So that really applies to Dataweave also, because Dataweave is also a library on the Mule platform. So it also progresses with the Mule version, but it's more of a scripting and it facilitates a transformation with ease. So it makes the API performance to boost up in a better way if the transformation is properly done. Otherwise, it will definitely impact the performance. It can give us big CPU hike if the weaving of the transformation was not properly done. So in this example, we are going to have a data weave which actually does the conversion of one form of data to another form. So here in this example, both form of data are JSON. I'm just going to pluck an element. Say for an example, this is my input payload. So I'm going to get an input payload for my API like this. So I'm getting a price as 12.5. So my output, it should be like 12.5 into 2. So what I was expecting is 25.0. This is a very small example. So ideally, the thing is, I'm just going to pick out the price element and I replace it. But I should have the same structure to be retained. So I'm just going to write a weave transformation for this. So to illustrate it, I just placed a mule simple flow. Like when I ask the API to give the input payload, it will give. When I ask give me the output payload, it will give the output payload, just to demonstrate it. So let us get started with our data weave transformation. I just created a data weave flow. So before doing the transformation, so we have an input and we have an output. So let us define the metadata, and there are two features which are there in the Dataweave which facilitates developers in a very good way. One is defining the metadata and another one is preview. Preview is to see the output. So whenever I'm doing some coding in the Dataweave, I should know like what is the expected output. If I just put payload, so it should give me some output so that I can visualize what I'm trying to do with the Dataweave. So preview is one of the important feature, and defining a metadata is to set, okay, this is my input sample data, so I'm going to play with. So it's not a fixed data, it's a sample data. So I can write a weave transformation based on the simple data. So let me define the metadata. So before that, I'm just going to copy my input payload. I have copied it. So this is going to be my input. So I'm just going to define the input metadata. I am just going to click add. So let me give the name like type. So type is to have a denotation like, okay, this input data is a placeholder which will be pointing to my input example or input schema. So I just created a type here. So what is a type actually? So as I said, both are JSON. So I've just selected JSON. So it is a schema or an example. I just shown you the schema. I'm just going to give an example. So before that, when I give an example, it really asks whether you have created any JSON example or not. So let us cancel this one. Let us quickly create an input JSON in our project. So let us go back to the SRC main resources. Let me create a new file, input data.json. Okay, let me just finish it. Let me just save it. Let me quickly jump back here where I have the simple flow established. So as I said, the data weaving transformation doesn't require your mule application to run and test. It doesn't have that pain actually. So you can set the input metadata, and you can write a weave logic here in this section, and you can just select preview. So right now when I click on the preview, the mule studio, whenever a preview button is clicked, so it will just run through the weave transformation. I just have the default transformation, that is output application Java. So it ran that default transformation, and it resulted me like, okay, yeah, when you run this transformation, it will give you a root of linked hash map. When application Java specified, it will be a type of linked hash map object. Let me define the metadata. So as I already defined the input metadata, I just need to select a JSON. So I'm going to locate an example because the one which I kept, it's not a schema, it's an example. So let me select that src9 resources, input data. Okay. So the input data is populated. Let me edit the sample data. So once I click on the edit, my sample data is populated here. Let me delete this and I'll give payload over here. So if you can see here, this is the payload, input payload. When I type the payload in the output section, so it just directly maps one to one. So I just got uh, the entire JSON as converted as a Java. So as I said, my contract is both input and output are JSON. I just going to pick up the price element 12.5 and I'm going to modify it to 25. So in a big JSON, so whatever the V transformation which I'm going to write will be helpful. So let me change it to JSON. So it get back me the transformation. So it does the one-to-one mapping over here. So I'm just going to pick up some elements from this structure. So the element which I'm going to pick up is price. So whenever a price is found, in case of here, or if the price is established over here, wherever price is, I'm just going to replace 12.5 with 25. That is my objective. So for that, let me declare a variable, because my variable indicates, yes, I'm going to play with this particular thing, price. So say for an example, if tomorrow I'm going to play with name or id, I can just uh, edit in this variable. So I'll say key to update. So this is the key I'm just looking forward. Okay, let me have it as an array. So because in future if I want to have multiple elements to be changed, I can change it. Price. Okay, so this is the key. Whenever the price is found, I should replace it. So the price value which I'm going to change 12.5 to 25. So I should declare a placeholder for that also. So I'll just declare a function. Function will be a lazy loaded one. Only when you call the function will be get executed. Unlike variables which get loaded when the data wave is loaded. New value. Price. Okay. So the function requires an input argument. Let me just give 25.0. So this function is going to be called and this function is going to return me 25.0. So before heading into the next step, I just need to do the simple logic of plucking the element. So whenever you are writing any logic, better to put it as a function so that you can reuse it in the data view if it requires at multiple places. So let me just, as of now, let it be payload. Okay. So let me write a simple function over here. Function change payload. Okay. So this function will get an input argument which is going to be a payload. I'll just declare input. Okay. So as this is an object, it's not an array. So it starts with curly braces. It's an object. So what I'm going to do is um, there are two functions in Dataweave. Like one is map, another one is map object. Map is going to give a array. Whenever you apply map on any object or array, it is going to give you a transformation, a lambda transformation, which is going to be a result output as an array. So whenever you use a map object, the result is going to be an object again. So the map object will give you the flexibility of operating with key value pairs. Unlike map will operate only with values. So map is something like a for loop which you are iterating it, you will have the index and the value. And map object is more like um, the index will be treated as a key and its corresponding values. So as it's an object, we are just going to pick up all the each and every individual elements. Even the tags can be an array. So whenever you are trying to pick out the keys, you can use either pluck or you can use map object. We'll use map object over here. So input, because I'm going to get this input, so I'm using inside this function. I am just defining a map object. So map object is a function. So inside that you need a curly brace like function. It's a set of things which is going to be operated. So I just defined a curly brace inside it. So whenever a map object is operated on any object, it is going to give me keys and values. How I can define a key? Key is denoted by double dollar. So this indicates it as a key. You can make it like, instead of this, you can make like this also. This is also a key. Okay. So this is my key. So I'm just going to find out whenever a price is found, I should try to find when a price is there, I should replace with a new price value. That is my objective, as I said already. So every time I'm finding out um, if it is an object, say for an example, tax is an object because it starts with curly brace. Whenever an object is found, I should recursively check whether the object has any price values or not. So in this example, tax is not having any elements as price. But if price inside this object is present, I should replace that. So more like it should be a recursive thing. Like, okay, unless you check it, so do that price checking, whether the price is there or not in every object tree, you should match. So I'm just going to make a recursive one here. Change payload. So ideally the input it requires. So I'm just going to pass a dollar. Why I should pass dollar? Dollar is nothing but the actual value. So when I should call this function change payload, when the dollar is also an objective tree. So something like when tax is matched, I should check whether tax has price inside it or not. When dollar is object. So when dollar is object, it is just going to make a recursive one to check what are the inner attributes of it, so that if a key is found, I should replace it. So if you can see here, it is erroring out. Saying oh, viable alternative, I should give a otherwise when is present. So I'll give otherwise. So otherwise what I'm going to do, it's a simple dollar. So only when an object tree is found, I'm just going to make a recursive one. Otherwise, I'm just going to print as it is. If it is a simple key value pair, I'm just not going to bother anything about it. But ideally, I'm going to pick out the price. It's a simple key value pair. So now the basic logic is done. So I should write like because I'm going to get values from this, and I'm just going to get keys from this. So only when my key is matched. So only when the key is matched, I should make 25, else I should do this simple logic. So let us mask this one with an unless condition. Unless, let me define another function like when I put unless, there should be a viable alternative where unless expects some boolean operator, a binary operator. So let me declare whether the key is matched or not. Let me declare a function over here. Find key. Okay. So this is going to get the key. So I'm just every time going to search, okay, the resulting keys of the object tree, whether it is really matched or not. So as this key to update is an array, so what I can do is simply key to update contains, because I'm just going to put array contains. So whether the array contains the element, the key is nothing but the element which I'm going to really pass exist or not. So it is something like array list that contains of string. So that's going to do a contains on the list of item. So key to update contains key. So this find key will give me a boolean only when the key is matched. So whenever a price array, like whenever the key price is found over in this key to update array, it will return true. So I'm just going to call that in the unless function. So unless find key, I'm just going to pass dollar dollar. So because it is just going to operate key, I should have it as a string because I should check over here. So let me cast it to a string. So I just wrote the unless function. So when unless is there, so it really expects the otherwise condition. What I should do. So otherwise, this structure should operate. So otherwise what I'm going to place is the key, the price, and I should call the new value price of dollar. So now I wrote the function. I'm just going to call this function. So see here 25, 12.5 becomes 25.0. So if I'm going to add price zero, see, so this is the power of Dataweave actually. So you don't need to really run this project from a developer perspective to test the weaving of transformation. It is very much fast and it is really flexible. Although it requires some simple learning at the start, once you get that picture, it is way faster to do the data weaving transformation in Mule. And it really helps the performance of the API. Unlike a Java code, which um, requires the compatibility with the Mule engine. Because whenever we are writing a custom code, whenever Mule is upgrading to another releases, this will create a bit of a problem because whenever they are upgrading into the newer version, so if you are keeping a Java code, the compatibility support, and even you may need to write the new functions, because you're not going to write a simple standalone Java code in Mule. You need often the pairing of Java code with MuleSoft libraries. So they will be upgrading the MuleSoft library. So in that case, you may need to really push forward with the functions, and that to the garbage collection mechanism of Java classes. And comparison to that, Dataweave is way powerful, and it is very much helpful to perform the transformation from a developer perspective. It is having a preview option. You can set metadata, you can set output metadata also. So hope you have enjoyed this small video. In the next video, I'll come up with another example to discuss, like, when a price is found inside an array. So consider tags as an array. This will not work. See for an example. See, when I make it as a tags as an array, it is not working. So because I wrote a code which is something like only it is an object, you do for the recursive check. Otherwise, just print it. So that's why it is printing. So I'm just going to see in the part 2 video of this to demonstrate the same example when tags is an array, how to plug the element, and how to make the data transformation work. So hope you have enjoyed this simple example. I'll come up with another video. Thanks.